In homework number 19, on question number 3, they have a question about asking you to find the critical t-values, which I noticed I haven't discussed either in the notes or other videos. So I wanted to discuss that now. As I say, it's question number 3 in homework 19. And let's say I'm going to give a little overview about this and then get down to cases with a couple of examples similar to the one in the homework. So let's say we're doing a hypothesis test where the significance alpha is 0.01, because that's what they have in that homework question in my printout. And let's say it's a two-tailed test. And so the critical region method, which is where these critical values come from. Now we've been doing the p-value method. The critical value method is another method that uses something called the critical region. The two methods are completely equivalent, but I want to show what's going on with the critical region method and what the critical values have to do with that. So if I draw this distribution, which is very similar to the standard normal distribution, but this is called a t-distribution. I'd go into a long math major discussion about that, but I'm not going to. Now with alpha equals 0.01 with a two-tailed test, we have what's called the critical region, where half of 0.01, the area of this region, is 0.005, which is half of 0.01, and the area of this region is also 0.005, which is half of 0.001. And this value right here on the edge of that is called the critical t-value, is right here. Critical t-value. The same thing over here, that's another critical t-value. And the region out here is called the critical region. Critical region. And the same thing for this part, this is the critical region also. Critical region. Now the idea with the critical region method is that when you find the test statistic, and the homework does ask for the test statistic, but we've never been using it in our examples because we've always been using the p-value. But if the test statistic is in the critical region, that's when we reject H null. And that's why they ask about the test statistic. Anyway, I want to get on to the idea of how to find these critical t-values. So I'm going to try to erase this board. Let's see if I can erase a clear canvas. Okay, so let's say that, again, let's go alpha equals 0.01, and they're asking this in the context of matched pairs. And let's say that there are 5 matched pairs. And they ask you to find the critical t-value. Well, the picture, again, looks like that picture before, but because there's 5 matched pairs, then what's called the degrees of freedom, or sometimes DF, is always going to be 1 less than the number of matched pairs. So in this example, the degrees of freedom would be equal to 4. So on the calculator, we can find the critical values by using the function called inv-t. Now let me go to the calculator. Well, let me just write one more thing here. Let me clear this one. So on the calculator, there's a function called inv-t, I-N-V-T, which is very similar to inv-norm in that you enter the area to the left and then the degrees of freedom, and that will spit out what's called the critical t-value. So for this particular example, we want to do inv-t, and the area to the left was 0.005, and because there were 5 matched pairs, the degrees of freedom were 4, And so that's what we want to enter in the calculator, inv_t 0.005, comma 4. Now let me show you where that is on the calculator. I'm going to switch to the calculator screen now. Okay, so on the calculator, it's in the same place where invnorm and normal CDF were. So if I go to this distributions, okay, and you see here's normal, CDF, and invnorm. There's inv_t is number 4. So if I go to inv_t, okay, now if you have the stat wizard on, it might prompt you a little bit more, but I'm going to enter the 0.005, which is the area to the left, inv_t 0.005, and then the degrees of freedom were 4. And when I hit enter, it gives me this minus 0.4604. So that's one of the critical values on the negative side. Let me get minus 0.4604. Let me get that down. Let me go back to this. So this is minus 4.604. So that's the negative critical value. And then the positive critical value will be positive 4.604. Let me just remind you what that chart looked like. So if I clear this, remember that the critical values were symmetric. Here was one of them, here's the other one. So this one that we found, here's the minus 0.4604. And then the other one, the graph is symmetric. This would be plus 4.604. And that would be the answer that they're asking for the critical values in the homework question. Now let me just do one more example. So they might ask, instead of alpha being 0.01, they often might ask alpha equals 0.05. So let's say alpha equals 0.05 instead of 0.01. Instead of 5 matched pairs, let's say that there's 7 matched pairs. Now here's the picture that goes with this. The critical t-values would be here and here. I'll call it t-crit. How's that? And here's t-crit. Now there's 2 of them because it's a 2-tailed test. That's what they ask in the homework. I don't want to get into the variation of a 1-tailed test here. Anyway, with that alpha equals 0.05, this time the area to the left of this one is half of 0.05, which is 0.025. And this area also is 0.025. Now, because there's 7 matched pairs, the degree of freedom would be 6, 1 less than the number of matched pairs. So on the calculator, I can figure out what those critical t-values are by going like this. Oh, I can just go right to the, well, let me write it down on the board here. So I can do this on the calculator. It's going to be inv_t. The area to the left is 0.025, and the degrees of freedom are 6 because the number of matched pairs was 7. The degrees of freedom is always 1 less. If I go to the calculator and I go to, what was it? It was distributions and then inv_t. And this time I'm entering 0.025. And now the degrees of freedom were 6. And that'll spit back minus 2.447 to 3 decimal places. Minus 2.447, minus 2.447. This is minus 2.447. And by the symmetry, the critical t-values, t-crit, I'll write it that way, would be plus and minus 2.447. Now, I just want to make one more comment about this. On some of the older calculators, they don't have inv_t. And in this case, you can use the critical t-value chart, which is in the book, and I have, I'll put a printout of it in the module for this week. If I go to the critical t-value chart, which I happen to have here, so it's the area in 2 tails. If you look, you can look it up on this chart. Area in 1 tail is 0.025, area in 2 tails is 0.05. And then if you look at the degrees of freedom, which is 6 here, and you go over this 2.447, Is that what we got for that? 2.447? Is that the same thing as we get on the chart here? Yeah, 2.447. So if you have an older calculator, you can look up the critical T values on that chart.